Before we graph this parent function, I just want to make some comments about quadratics and parabolas, just as reminders. So I would say just kind of remind yourself that parabolas or quadratic functions are symmetric. And today's the 21st. So they're symmetric. So what that means is if you only really need half of the graph. So once we get half of the U shape, we can reflect it over. So we only need half of the graph and the vertex. Then reflect across the axis of symmetry. Now we're also going to talk about other ways to graph, and I will let you guys decide which you like better. So this is one of the more common ways is you get half the graph, and then you just reflect the points over, and then you're good. The y values stay the same. You have to just change the x values. So this is one way, and then we're going to talk about another way in more detail that I personally like better, but you guys might not, in which case you can just use this reflection idea. But don't ever forget that parabolas are symmetric, okay? So that's a key there. So let's spend some time in graphing our parent function in detail, okay? So we've done this a little bit before, but I'm just going to create a table of values. You guys don't need to if you don't want, but let's just go through it together. So when we plug in 0 for x, what do we get out for y?
0.
0. Okay, and then let's plot that point. 0, 0. When we plug in a 1, what do we get out for y?
1.
When we plug in 2, what do we get out?
4.
And even though it's off this graph, when we plug in a 3, what do we get?
9.
Okay, so we're going to be about here at 9. And then let's keep going to the other side. So at negative 1, what do we get out?
1.
Negative 2, we get?
4.
And negative 3, we get?
9.
Okay. So make this look really nice on your papers. Connect it with a smooth curve. Every graph looks like this. It's some variation, right? That's why we have parent functions. They tell us what the graph looks like. They tell us what's going on. All right, so I want you guys to just kind of remember a couple things. So one, we've already identified this, but it doesn't hurt to say again, this is our vertex. And for the parent function, the vertex is at 0, 0. So let's make one comment here. Your vertex is the most important point. Most important point. All right. So regardless of what's going on, this is always your first step, right? You always have to find your vertex first. And we now know how to do that, right? We use our axis of symmetry equation, and then we plug that back into the formula. So vertex is the most important point. You need to find this first. So find first. But once we have our vertex, everything is always a transformation of the parent function, right? So we talked about that with absolute values in detail. So let's go into detail and look at this graph about what's going on. So the first thing that we want to find is this first point. We're going to focus on just the right side because we can just reflect everything over, right? So this first point, to find this first point right here, all we have to do is we go up 1, right 1. That's it. That's always going to be true when our leading coefficient is 1. So then we can say when, and this would also way up. So when A is 1, right? So when A equals 1, that's our leading coefficient. Let's write that as an equation. How about? So when A is 1, then we can say our first point. After you find your vertex, your first point, we simply go up 1, and then right 1. That's all you do. This works every time when A is 1. If A is negative 1, what do you think you do?
Up 1.
Do not go up 1.
Or down.
Down 1, right 1. right? The only thing you're doing is changing the y's. The x's are going to stay the same, so we're going to go up 1, right 1. All right, so then let's look at our next point. Our next point is right here. We're going to go up 4, right 2. Okay, so that this is still when A is 1. Our next points, this is first point and second point. We're going to go up 4, right 2. And we can actually keep going. So on our graph, we could say that, okay, the third point, which we normally don't need, just having 2 points is fine. We could go up 9 and write 3, but we don't need to do that. So we'll just stop at these. Now let's think about absolute values. When we changed the A, what did that do to the graph? Think visually. So we had our V-shaped graph. What happened when we changed the A value?
The graph like steeper or
okay, it got skinnier or wider, right? Steeper or wider, right? Or fatter, however you want to say that. It's the same thing that's going to happen here. If you change your A value, the parabola, if the A value is bigger, the parabola gets skinny. If the A value gets small, like 1/2, 1/4, 1/8, it gets wider, right? It's the exact same thing. So here's a better way to describe how we're going to do this, and this will always work, right? So this is going to be, so when A is any number, and this works when A is 1, when A equals anything, whatever you want, positive 1, negative 1, 0, whatever, the first point, and this is all only going to be affected by the y value, so we're going to go up, we're going to go up A units, so go up A, and if A is negative, then you just change the word up to down. And you're going to go right 1. That's really nice. The second point, we go up 4 times A. So 4 times A, right 2. This will always work. A is simply, it's a vertical stretch or shrink, right? We've seen this A value with absolute values. We call it a slope with absolute values. Here it's just going to change our how much we're going up, right? So it's going to stretch or shrink our graph. And this is all we need to do to counter points. You guys can plug in values if you want. So you could find your vertex and just pick a couple values to one side, right? Plug them in, see what happens. This is going to be a lot quicker though. So if your A value is 1, just go up 1, right 1, up 4, right 2. Or if it's anything else, just you're going to go up A values, right 1, up 4 times A, right 2. This works 100% of the time. And then once you know one point, you can either reflect it across, or instead of going up 1, right 1, you can go up 1, left 1, up 4, left 2, right? You can just count it that way. Counting is much, much easier in these problems. All right? So this A value, that's your leading coefficient. Today's focus is just that leading coefficient. As we look at, we get into more graphing on Monday, we'll extend this, but for now we're just focused on that leading coefficient. So once again, the most important thing, we have to find the vertex first. And then from the vertex point, this is how we're counting, right? We're counting like this from the vertex point. Okay, so let's just start working together. Who can give us, just fill in our axis of symmetry equation for us. So we got an x equals, Ryan, what is that?
4 over 2.
Okay, so our axis of symmetry is that x equals 2. If it helps you, you could actually fill this in right away. And so you could actually go ahead and say, and plug this in. So let's see, we could even do this at x equals 2, which is right here. We could go ahead and we now have this, right? There's our axis of symmetry. Okay, what do we do next? We have our axis of symmetry. Okay,
Find the vertex.
okay, have you done that?
Yeah.
Okay, so when we plug in 2, what do we get out?
2.
Okay, so 4 minus 8 plus 6, we get out of 2. So the y value is 2. So our vertex now is here at this point. Okay. Everybody, is this graph going to open up or down? And then you said at first what, or how did you know that?
Because your n is
Yeah, this a value, which is a 1, is positive. So you know the graph opens up, and then we just think about that counting pattern. Well, all we're going to do to find our points is we're going to go up 1, right 1. That's the first point. And then we're going to go up 4, right 2. That's the second point. You can plug in values, so feel free to plug in 3 and see what happens. You can do 3 squared minus 12 plus 6. You'll get out 3, right? You can do the same thing with 4. This will work. Up 1, right 1, up 4, right 2. And if you want, you can either think about reflecting this over, or you can count up 1, left 1, up 4, left 2 to get to here. And then we would draw our parabola with the arrows, and that's it. All right, so let's get some work on the board. Let's keep with our volunteers. Will, fill in the axis of symmetry for us.
Alright, -2, 2, -3.
All right, so plug in this 1. Now be really careful when you do this. You get the opposite of 1 squared plus 2 minus 3. So this is -1 plus 2 minus 3. So the y value, you're going to end up with a -2 here. Everybody, does this graph open up or down?
Down.
Okay, this opens down because of the negative in front. So now we're going to go down 1, right 1, and then down 4, right
-2,
2.
-2. Alright, -2, 2.
Thank you. I'm just off by 1 here. Oh, how about this? Thank you, Will. And then here and here, right? So down 1, right 1, down 4, right 2, down 1, left 1, down 4, left 2. There's our graph. All right, so let's keep going with these. Somebody fill in our axis of symmetry for part C. Yeah?
-6 over 2 is -3.
Okay. So then we plug this in. So -3 squared minus 18 plus 1. So it looks like we're going to get a -3, comma, is that a -8? So plot that point, and once again, if you want, you can draw your axis of symmetry through -3. So we have an axis of symmetry here. And then we're going to be down at -8. So we're going to be actually right about here. And then our pattern, we're going to go up 1, right 1. And then we're going to go up 4. So from 8, that would lead us to here, right 2. Up 1, left 1. Up 4, left 2. So our graph should look like this. These graphs should all look the exact same, right? All we're doing is moving them around, maybe flipping one down. This next one, though, should look a little bit more different. So somebody fill in our axis of symmetry equation for us, please. Right?
You want to divide 4 and 4 here as 1.
Okay. So 2 times 1 squared minus 4 plus 2. So it looks like we're going to get a 0 here. Is that what you guys got? All right. So if we want, once again, we could draw our axis of symmetry. We don't have to do that part. And then we could, okay, here's our point. Does this graph open up or down? Okay. And then our pattern now, instead of going to be going up 1, right 1, we're going to go up 2, right 1. And then it's up 2 times 4, so then we're going to go up 8, which is right about here, right 2. Up 2, left 1, up 8, left 2. There's our graph. Okay, so somebody new, axis of symmetry, fill it in for us, please. Phil.
Oh, on that one. I got 2.
Okay, but fill it in.
Oh.
This one's different. Kind of.
Okay, -1, plus 4 minus 6 would be.
So how did you get your axis of symmetry?
Oh, sorry.
Fill that in.
Yeah. Negative 2 over 2 times negative 1/2, so negative 1, which is 2.
All right.
Sorry.
So just be careful with if you give fractions. I don't think I put any fractions on the homework, but certainly it's possible to do that. It works just fine. So then we just plug that in. So this is our x value. If we wanted to, we could, at 2, draw our axis of symmetry right there. All right, so now when we plug this in, so y equals negative 1/2 times 4 plus 4 minus 6. So minus 2 plus 4 minus 6. You guys get out a negative 4?
Yeah.
So if you disagree, just check how you did this. So if you're plugging in a 2 here, 2 squared is 4, and then multiply by negative 1/2. Make sure you're following order of operations. Plus 4, so that would add to a positive 2. Minus 6 is a negative 4. All right, so then let's plot this point 2, negative 4, which is right here. Does this graph open up or down, everybody?
Down.
Down. Okay, so now we have a negative 1/2 up front, so we are going to go down 1/2, right 1. So that's right here, in between the lines, that's okay. Down 1/2 times 4, so that's down 2, right 2. Down 1/2, left 1, down 2, left 2. And this graph should be wider than the others, which it is, and that makes sense because this a value is smaller, as we've seen before. The smaller the a value, the wider it gets, the larger the a value, the more narrow it gets. So it's going to be the same thing here in this problem. Let's fill this one in. So somebody fill in our axis of symmetry equation. Let's hear from new people. No, new people. Lily.
It's negative 6 over 6, which it means x equals negative 1.
Awesome. So we can draw our axis of symmetry if we want. It's right there. And then plug this in. So 3 times negative 1 squared plus 6 plus 1. So 3 times 1 is 3, plus 6 is 9, plus 1 is 10, correct?
It should be minus.
Thank you. Minus 6. That makes it better. Minus 6 plus 1. So now it looks like we're going to have 3 plus 1, which is 4, minus 6 is negative 2. So negative 1, negative 2. Is that where we're at?
Yeah.
Yes. All right. So this graph open up or down?
Up.
Up. And then we look at our leading coefficient. We're going to go up A, right 1. So up A, 1, 2, 3, right 1. And then 1, and we're going to go up 4 times 3, so that's going to be up 12. So there's 1, 2, and then we're going to go up 10, so it's going to be about here over 2. Then go up 3, left 1, and then up 12, left 2. This graph is very narrow, which makes sense because the a value is getting larger. A lot of you guys have talked about, I heard you talking about what this picture looks like. So if we just got a really, really quick sketch. When you're kicking some ball, right? So if you start here, it's going to look like this. And we don't need to add any numbers, right? This is what this looks like, more or less. Okay, so that's what this is going to look like, right? So let's actually try to fill in some numbers here. Starting with this point, so if this is the initial point, thinking about time and feet, this should be 0, 0 if we were on a graph. So plug in 0 for x. Do you get out 0 for y?
Yes.
Yeah, which makes sense. So this is one of our points. Now, we're asked to find the maximum height. Nelson, what's that really saying?
Define the axis of symmetry.
All right, so we're dealing with the axis of symmetry. So since you said that, can you fill that in for us?
Yeah. It would be negative 64 over 16 times 2, which is negative 2.
Yeah, I meant for this to be negative.
2.
So you get out of 2. So this is our time, right? X is the time in seconds. So after 2 seconds, here's 2. We're going to be at the maximum height. Okay? So then, how can we find how high this moment. Oh,
Plug it into the equation.
okay, so then we have f of 2, or y equals negative 16 times 2 squared plus 128. Alright, so negative 16 times 4 plus 128, which is also negative 64 plus 128. So 64. So this is the point 264. So we have two of these answers. So the max height is going to be 64 feet. And then the time it took to get there is 2 seconds. Alright, we have not talked about how to figure out the second half of this question. So you guys can do it without us having to say anything. Patrick?
4 seconds.
Keep going.
It takes 2 seconds to get there, so it has to take 2 seconds to get back. Yeah.
Graphs are symmetrical, so the total time is just double 4 seconds. Awesome.